Emma is making a scale drawing of her farm, and she's using a scale of 1 centimeter is equal to 2 5/10 feet. In the drawing, she drew a well with a diameter of 5/10 of a centimeter. What is the actual diameter of the farm? So I'm going to use math for this, and I'm going to use her scale as my first ratio, where 1 centimeter is equivalent to 2 5/10 feet, and our unknown is what is the actual diameter when we have 0 5/10 centimeters. So here we go. Let's do this. And right now this is feeling so much like second nature. You know exactly what it is you're going to do. You know that n is going to be equal to 2 5/10 times 5/10. So I'm actually going to just do this one out. I have 1 25/100. And let's put that into context. The actual well has a diameter of 1 25/100 feet. So you can stop there and hit pause and jot this down into your notes. Things I really want you to know is notice how I'm using the scale. So if I know this is what they're giving us in the problem, that is the first ratio I'm really expressing here in math. And I'm using that to figure out my next equivalent ratio. Let's look at our second problem, and this one is a little bit more complex than the first one. Dale bought a map of his city. It uses a scale of 1 inch is to 8 miles. Dale's house and school are 1.5 inches apart on the map. How far apart would his house and school be on the map if the scale was 1 inch to 6 miles? So this is what's complex about this. We're actually seeing there's an original scale, 1 inch is equal to 8 miles, and we want to change the scale to 1 inch to 6 miles and figure out what the distance would be on that map. And that's our big question. What's the distance between Dale's house and the school on the map if the scale was 1 inch to 6 miles? We know the original scale. We know the distance of the house on the map, not in real life. His house isn't 1.5 inches away from school. And we know the new scale would be 1 inch to 6 miles. I'm going to model 2 different methods for this. And here's one method where we're going to use math to represent the scale and the distance on the map. So I'm going to express that as a complex fraction, 1 to 8. So I'm changing the scale from 1 inch equals 8 miles to 1/8. And I'm setting that proportional to 1.5 inches to what's on the map. And my second ratio is going to be my new scale, 1 to 6. So 1 inch equals 6 miles to figure out what that distance would be. And I would just solve for n using my cross products. Or if that sounds too complicated, taking the scale and turning it into a ratio, I can use math to find the real distance on the original scale, and then use that number to find the distance with the new scale. So I'm going to show you both of those in a second. Do me a favor and let's put a star next to which of those 2 plans makes the most sense to you. Which one would you do? And then I'm going to model it out and you can make a decision on which one makes sense to you after seeing it visually. Hit pause and jot this down into your notes. I've set up both methods. I'm going to start with the easier one, which is the one where we're just using math. And on this method, I'm going to use what we already know, that 1 inch is 8 miles. And I'm going to do this to figure out if this is 1.5 inches, how many miles is this? All right, so this is first, I'm going to find the actual miles. And then I'm going to use that to put in the new scale, like if it is 1 to 6, what would the new part be? So I'm going to do the same as we normally do, cross multiply, and we're going to get n is equal to 8 times 1.5, or n is equal to 8 times 3 over 2. I'm showing all my work so you can see where I'm getting my numbers from, and I get n is equal to 24 over 2, or 12 miles. So the actual distance between his house and the school is 12 miles. So I'm now going to use that number and put it here, 12 miles. So if this is now the second one, this part up here was to find the actual miles. And now I'm going to use the actual miles to find the distance on the map. Okay, so now this is my unknown number. And I'm going to do the same, cross multiply. And I'm going to get 12 is equal to 6n. Divide both sides by 6. N is equal to 2. So I'm going to put that into context. On the map, with a scale of 1 inch to 6 miles, the distance would be 2 inches. So that's the first one. You can hit pause and you can jot this one down. And now we're going to try what if I did it in just one step instead of doing the entire math process twice. So in this one, I'm going to use the scale 1 to 8. So my proportion is the scale and then the distance in inches. So watch how this looks, Math Marble. So if it was 1 to 8 on the map, it would be 1.5 inches. And my question is, if it's 1 to 6, what would this be? So again, I'm going to just cross multiply, and it is a little bit more complicated with the numbers. So on one side I have 1.5 times 1/6 is equal to 1/8 times the number. Let's change these to friendlier fractions to work with. And I can multiply 1 times 3 is 3. 2 times 6 is 12. 3 twelfths is equal to 1/8 times n. And now I'm going to divide both sides by 1/8. So you can see it. 3 twelfths. And instead of divided by 1/8, I'm going to multiply it by 8 over 1 is equal to n. Okay, so I'm not compounding, I'm not skipping steps. Just so you can see, all I did was rewrite it there. And finally, I get 24 over 12, or 2, is equal to n. So it is the same number. N is equal to 2 inches. So I would write down the exact same answer on the map with a scale of 1 inch is to 6 miles. The distance would be 2 inches. So both methods work. And again, use the one that makes the most sense to you. And again, I did this because the scale changed. So if you find that this method works better, where you're finding the real distance first and then changing the scale, if that works for you and makes sense and you're less likely to make a mistake, then do this in 2 steps. If you find that you want to try this method where you're taking the scale and using the proportional, making it proportional to the distance in inches, you can do this. But when it comes to an exam or a test, try the method that is the most consistent and accurate. And with that, that's the end of our lesson, Math Marbles. I'll see you in the next one. Take care.